Good evening, everyone. I hope I'm audible to everyone. All right. So let's cut to the chase and start. A quick introduction about myself. My name is Anant Shrivastava. I have about 15 to 17 years of corporate exposure, ranging from being a server admin to being a developer to being an information security professional to now running my own small company. So bunch of different areas that have been explored. I've been a speaker and trainer at a bunch of different conferences. I like to do a lot of open source work. So there are a bunch of different open source projects that I run. Primarily Code Vigilant, where I do source code audits for open source projects. Tamer platform, where we try to do Android security. And Hacking Archives for India is more of a collection of all information security conferences that are happening across the globe, but where Indians are presenting. That's my handle, where you can find me at Anant Shri on all different social media profiles. So today I wanted to talk about supply chain, and then there are a bunch of things that are very obnoxiously familiar for people when we talk about supply chain security because of the way the vendors have been pushing across. I wanted to kind of give a feedback as well as kind of do a comparison of what actually supply chain security looks like versus what is being sold right now, where we are, and what are the things that are still needed to be done in this space. So taking software out of the supply chain, if you look at supply chain, what you see as the diagram is a two-sided approach to build a laptop. On one side, you have raw materials which are being procured, and then intermediary material being created, to the semi-finished laptop material being created, to finally a laptop being created. Once a laptop is manufactured, then the next set of process goes on, where from a supplier to a retailer to an end customer is where the laptop is being used. So what we see here is that there is raw material or providers, there is intermediaries in picture, then there is a consumer who has consumed all of this and created a final product, and then there is a chain which ensured that you receive the product, and then the end user who is actually leveraging the product and using the product. Putting supply chain in a software concept, this is what the diagram would look like. There would be four primary entities involved. There would be a producer who is basically creating the basic building blocks, what we generally call as third-party libraries. A very simple example of it would be libcurl in Linux, or maybe Linux kernel itself could be a third party which helps you build the entire product. Then comes the consumers. These are software manufacturers who are basically leveraging on these third parties and creating the next step. Now, consumer could also be the intermediary who is then creating something where they become the producer, and the consumer then is a higher level entity which is leveraging this software that is being created. So this could be a cyclic loop that gets created. Whatever artifacts that are created need to be stored at a place. So this is where the infrastructure providers comes into picture. So when I say infrastructure provider, I am talking about S3 buckets to Docker Hub to your cloud service provider accounts, to anything where once your work is done, you're sending across the artifacts to be stored at a central place, decentralized place, a separate place than your development environment. And the last part is the end user. They are the people who are actually using your code or using your software. Now, if I re-simplify it, put it across from a development point of view, these are the 6 building blocks that you would find whenever you're developing a software. On one end of the spectrum is a software developer who's basically writing code. On the other side of the spectrum is a software, or rather a service provider, something like Azure, AWS, cloud, whatever cloud vendor you may have, whatever containerization environment you may have, which is where the final deployment happens. In between the chain, there are code repositories, there are CI systems, there are CD systems, there are containers, there are dependencies. All of this formulates your supply chain. And when we are talking about securing your supply chain, we have to look at the entire chain in that whole context. Now, the fun fact is, when people talk about supply chain, we are actually talking about establishing trust. Can we trust the entire process, that there is no problem in the entire process? and we have received the final product good and handy. The concept of not being able to trust the software is not a new concept. The very relevant paper that a lot of people would kind of reference is this article from, or rather this speech from Ken Thompson, which he did in, I think, 1984. And he talked about trusting, or rather establishing trust. And this was the first scenario where, in computer's context, a publicly available document was talking about how to backdoor your compiler. So irrespective of whatever your source code is, the compiler would ensure that a backdoor is always present. But this was not the first thing or first written document which actually talked about this. This is the part which a lot of folks miss, because a lot of us in software don't like to read a lot. So if you scroll down to the second page of that article, there is a mention that there is an Air Force document which was the actual first document talking about this particular scenario. So I was trying to figure out where that document is, what was the reference and how it was. So this is the document that I could spot. This is, if I read it right, it's 1974. That's when for the first time someone thought about, hey, we're talking about building softwares, we're talking about compilers, and we're talking about n number of things, and we're building trusts based on these entities. Are these entities 100% trustable? Can they be backdoored? Can something happen to the entire process where my input is always benign, but my output is always malicious? So the concept is not told. Now, OWASP, I think everyone knows about OWASP. OWASP has been shouting about this from the top of their lungs from the very beginning. Right from 2004 till 2021, now they've actually got a proper name for it. Vulnerable and outdated components, or using components of known vulnerabilities. Effectively, what I'm saying is, when a vendor says software supply chain is a very big problem, it's a very new problem, you're not aware of it, and it has never existed before. It has existed for a very long time. It's just that people didn't have something to sell us, so they didn't have something to talk about. So now when they have something that they can sell us, now they're talking about it. Now, like I said, it's been known for a decade. What changed? So the things that changed was, one, an executive order came out from the President's office at United States. And what was the reason why that came out? This is a very interesting analogy that I'll draw later. There was SolarWinds hack that happened. There was CodeCov hack that happened. There was Colonial Pipeline. Mostly Colonial Pipeline and SolarWinds were the primary ingredients which pushed the US department to say, hey, there's something going wrong. We need something to be done here. Now, what actually happened because of this? Because of this executive order, which effectively told NIST, which is the other government body in USA, that, hey, you need to work with the other departments, come up with a framework. How do we secure ourselves? This was not for the world. This was not for everyone else in the world. This was a specific order for a national body to devise a framework to secure US government softwares. Now, because they do all things in open, they put out their frameworks in open, a lot of us leverage that. There are other frameworks that come into existence, but a lot of us leverage NIST related documents. So at the end of it, NIST came up with SSDF, Secure Software Development Framework, and Google and other parties came up with a framework called SLSA. We will very briefly touch about both of them. The industry buzzword that were taken out from this whole process were two. One, software bill of material. Two, provenance. So a software bill of material, in a very layman term, is like when you go to when you go to a kitchen and you want to cook a recipe. You open up the recipe book and it has a list of ingredients. You procure those ingredients and you make the recipe. So this sort of is a document which tells you what is your software composed of. And random buzzword facts that you will find in all vendors, 80% of your code is not written by you, 80% of your code is written by someone else, and you're leveraging that third-party module. 80% of code in your software is not written by someone else. Very valid fact. What I've also found is a large number of times, a large chunk of that code is not something that you're using. You're leveraging a library for 10% of functionality, but you're importing that library with 100% of its code and making it your own problem. This has a relevance as we move forward with this. Provenance is effectively a proof that whatever document, so software bill of material being a document, is authentic. No one has tampered with it. So you need to establish provenance. That yes, whatever document you're receiving from me, that this is the list of ingredients, these documents are actually authentic documents. Now, I have these funny thoughts in between, so you'll find them. My assumption and my understanding of the software industry is we end up solving problems that we created a few years or a few months ago. We keep doing that circle. We've been doing that for a very long time and we'll keep doing that. So not exactly a problem, but looking at the steps in which we have reached this current situation. We've been trying hard to automate software building and development processes. So when your software can be built faster, there would be quicker release cycles. We've all seen from waterfall model to agile model to releasing once every 1 hour or once every 10 minutes. That kind of release cycles. When you have these kind of release cycles, you can't do it manually. You have to rely on an automation. So when there is automation in picture, there is less wait for new features, because as soon as I have written a feature, I have to click a button and that would automatically create a release and the release would be out. Well and good. Everyone gets the new feature as early as we can produce it. Because there is very fast, frequent release cycle, you end up with softwares which are getting released, say, once every week or once every 2 days. There is less and less interest in developers going about trying to upgrade their dependencies. Because I started working on my software today, and by the time in 5 days I'm done with writing all the code that I wanted to write, there are 3 version releases on the library that I was using. That becomes too hectic at one point. The other problem that comes is a large chunk of software supply chain security related paradigm that you would see is focused around open source softwares. The funny thing is, no organization, or rather most of the organizations, never have a service provider agreement with an open source maintainer. Yet it's the open source maintainers' responsibility to keep their code secure, to keep their code updated, and to ensure all the compliances are followed. So it creates a situation where the developer might not even be interested in doing all of that. And in old days, if there are people who have been in this circuit for 10-15 years, you would remember the days when there used to be 2 different release cycles. There would be a feature release where new features would keep on coming, and then there would be a stable release. Only bug fixes go into that release. And after a while, a feature release would become a stable release, and then the bug fixes would go there. Now, because of all this pressure around creating and churning out code, people have stopped doing that segregation. You get one stream. You have features, 1, 2, 3 release, 4th release has a bug fix, 5th release has a breaking change, 6th, 7th, 8th have feature releases. And it's just one single stream of releases that you're receiving. So it becomes an overhead on the developer part who's basically importing that module to decide what to do with it. Problem? So a solution. We built automation which informs the software developers every single time a new release is created. What you see at the bottom is the list of bugs or issues that Dependabot has created on GitHub platform to inform software developers that there is a new version of library that they are using. Now, this is one example. I've intentionally removed the name of the projects and the other details wherever I could find relations. But effectively, my question to them was, hey, you're releasing software at the frequency of 1 release every 3 days. How can I keep track of it? And their answer was, we don't have the capability to maintain segregation between feature fixes, bug fixes, and other releases, so we keep a single stream. We recommend you use Dependabot and automation to perform all the upgrades. Now, this is where the fun starts. So another friend of mine having a conversation around software development, and their problem, hey, we keep getting these dependabot requests, we can't update it because there may be regression, there may be some problems in the code which can break the build. My answer, and this is like a proper security professional trying to just say, hey, you're not even looking at the right things. Like, have a proper automated build process. An automated build process would ensure that your build, if it is broken, would be informed to you. So you would get an immediate notification. The response was, yes, if the build process works, but if a feature fails while I am actually using the product. The next question from my side is, have test cases. If you have 80-90% test coverage, it is so simple to identify such flaws. Anyone here who is a developer? Did you started laughing when I said 80-90% test coverage? Yeah, see, that's the problem. Test coverage is never going to happen. If it happens, then maybe the automations would reach a point where the utopian security dream of I push a button and everything gets updated, the entire world is running on the latest version can happen. That's not happening in near future anytime. So what the business is right now trying to do, the industry has a few fun objectives right now. Find and report as many third-party dependencies that are in use, which are older versions, and try and get them fixed. That's a big project. Create inventory, because that's what US government has asked us to do. Validate inventory signature, because the US government has said that, hey, you need to validate. Because these are the two things that you can do automated. These are the two things that can be programmed. So these are the only two things that can be productized and sold to you. So that's what they're doing. And then at the end of it, everyone feels good, hey, we saved the whole world. This is the image that I generally use when I'm talking about me being a security professional, talking to developers. This is kind of how I've done a lot of times. So yeah, you get the gist. So enough of rant. What exactly is software bill of material? Anyone here who has seen NIST Cyber Security Framework version 1.1 would recognize this diagram. Of the entire framework, there is one line item which says identify. Effectively, that whole line item talks about if you don't know your assets, you cannot protect them. SBOM fits into this particular block. Know your environment. That's all SBOM is trying to do. So what is SBOM? A list of ingredients, software name, version, checksum, license information, dependencies that you are using. Generally, what you will find in SBOMs is a one-level depth of dependencies that are used by the software. So if I'm a software manufacturer, I've used 10 top-level dependencies. I will list those 10 top-level dependencies in my SBOM. The assumption is all these 10 would have their own SBOMs, which would be listing their one level down dependency tree. So the SBOM trees are supposed to be built by plugging in all these smaller SBOMs into one giant SBOM, which has all the ingredients mapped across. Now, what it does not contains, what compiler was used, what ML model is in use, because yeah, AI, everywhere AI is there. So there is some ML models in use. You don't know which ML models are in use. What SaaS services were used? Did you compile it on GitHub, or did you use GitLab, or did you use a Jenkins solution? You don't know via looking at an SBOM. What operating systems were in use? This is again an information not provided. There are a lot of other information which SBOM cannot store inside it. This is where a simple shout out to OWASP Cyclone DX project. If you go to the website, they actually talk about these problems, and they're working on trying to create more bills of material. There was a talk, I think 2 days ago at Black Hat EU, where a different party was talking about cryptographic bill of material. What are the cryptographic ingredients used in your libraries across your entire code base? They were trying to build a cryptographic bill of material. So, bill of material is a keyword that you're not going to stop hearing for next 5-10 years. This is the in keyword now. What SBOM can help you with? Identifying that one tiny software that is sitting and doing a lot of work for you. When there is a curl CVE, which is say 9.8 CVSS score, you want to know, hey, how many of my softwares are actually using libcurl? If you have a proper SBOM system in place, you'd be able to query that environment and get those details. If you are a 3-letter company and you have incidents like log4j, you won't need 45 days to look up into every single inventory of yours to identify how many of my projects were using log4j and trying to provide fixes for them. So this was a joke around where when log4j incidences happened, there were a couple of organizations who would need 45 days or 50 days time frame just to go through their inventory and tell you, hey, you know what? 20% of my softwares had log4j and we have fixed that. That kind of a cycle that was going on could be prevented if SBOM is there. So end of it, any inventory problem can be solved by it. That's the whole purpose of SBOM. Now, fun fact, if you remember, I talked about Colonial Pipeline, CodeCov and SolarWind being the initiators for the executive order. Even if SBOM was there, even if provenance was set for SBOM files, SolarWind could not have been prevented. SolarWind hack happened because CI system got compromised. There is nothing in these SBOM specs which talks about what CI systems are you using. So that's where it's a solution to a problem, not the solution to the problem that was in place and not the problem that people are trying to solve. It's a solution to something. Plus, it cannot actually tell you if the bug is in your code or not. Like I said, you're importing 80% of software code from some party, but you're not using all 80% of it. You're using a tiny fraction of it. If your third-party dependency has a bug, there is a very big chance you might not even be using the path that goes to that bug, and you may be secure from that. As of now, the standard SBOM spec does not have anything around it. There are attempts. CycloneDX is one of the parties who is actually trying to do attempts around it. VEX is the spec sheet that they're creating, which should talk about, of all the CVEs that are against my dependencies, these are the ones that are applicable to me and I've provided fix for it. So that sort of detailing is coming up slowly and steadily. Now, like I said, it's not the end of all solutions. It's not the final solutions. It's a good first step. We needed this. We desperately needed this. Anyone here who has ever tried to solve inventory management problem in their organization and has said, hey, I'm done with it, maybe quit jobs? Look at the state now. There is a government entity, and rather government entities across the space who are basically telling software developers, hey, we need inventory. We need you to do the inventory. And the way the system is working, if you are a top-level seller to the government entities, you have to be compliant. But because of the way SBOM works in a cascading manner, every single entity that is doing business with you or the entity next to you, all of them have to become compliant at one point. So I am hopeful that inventory problem, if it would not go away completely, would be solved a bit. We would get closer to having better inventories in our environment. Now, has the world never done anything about it? Is this the first time things are happening around third-party components? Has no one ever tried anything? So there have been two major approaches that you would have seen in software development, and you would not consider them as a supply chain management problem per se. They've been doing their job, but it's kind of helping in the supply chain ecosystem. On one side, we have a centralized approach where effectively one party takes care or takes the ownership that I will maintain this ecosystem. Any software that is getting installed in this ecosystem, I will ensure the security updates are in place. The other is a decentralized approach. I want to use the latest third-party module. So I'm going to create this container where I'm going to do all my work and I will not affect the main operating system. Now, vetted software is where, now from this point onwards, any example that I'm giving I am talking about open source code. There could be a proprietary approach around it. There could be a closed source approach around it. But this is mostly from a focus of open source code because it's easier to relate for masses. So in a vetted software ecosystem, you have volunteers or you have paid people who are basically looking at a specific set of softwares. A very simple example of it would be the Debian ecosystem or a Linux distro ecosystem for that matter, any distro if you take up. They maintain a list of officially supported libraries that they have. Any security bug that gets fixed, released, gets merged into the library, and they maintain a feature release and they maintain a bug release. The problem with this approach becomes that on one side, it's a single entity who's taking care of things. It's easier that way. There is one point you can deal with it. On the other side, because it's a single entity, they cannot take care of the entire world. So they'll have to put some restrictions. One of the major restrictions that come is, I will only maintain these 100 or these 400 or 500 entities and I'll not go beyond that. So if you want to use the latest software or the latest third-party module that came out just tomorrow, you may not find that in your repositories. So there are restrictions focused towards the stability, but it gives an advantage that you don't have to worry about things and there is a third party taking care of things. On the other side, isolated software approach, which you find in NPM. Anyone here who is a Node.js user? When you do a NPM install, go into that folder and look at a folder called node modules and do a right click on that folder and say, tell me the size of this folder. If it is less than a few hundred MBs, you are in a very, very restricted project. Node modules is a folder which basically just downloads all the dependencies that you have, cascading down to every single entity that you may have. You may have top level 10 dependencies, which may result in, if it's a smaller project, about 500 dependencies in total on a Node.js module system. So all of those modules would be available in that Nodes module folder. But that's what it gives you as a flexibility. You can use an older version of module, you can use the newer version of module. You don't have to worry that if I upgrade this module, I'm going to break every other Node.js software that I have in the system. Everyone is working in an isolated containerized environment. In Python ecosystem, you have pip and venv. Venv is what does this kind of a job for you. Now again, devs have control is a pro as well as a con. Now dev has control, they need to know that there is a problem and then only they'll be able to fix it. NPM has been trying to do something around it. There is an npm audit command. Whenever you do an npm install, it tells you how many vulnerabilities are there. But that's about it. I know my software stack has a vulnerability. What do I do about it? The most common response is, remove the dependency. Yeah, but if the dependency is an OAuth library that I'm using for single sign-on feature of my application, maybe removing that dependency is not a good idea. So, with a lot of these problems that we've created for ourselves, which we have been working on over a decade to try and smooth the whole process and bring more automation, there is some good features that have also come up. We now have infrastructure as code, or rather as a code feature. Everything is becoming as a code. Infrastructure is a code, compliance is a code, policy is a code. Anything that you could think of is now becoming as a code in software development environment. We have better cryptographic standards, obviously a general evolution that has happened. We now have hardware, software, and storage capacities where we can maintain provenances and maintain a third-party storage which can give us some sort of an assurance. Now, I used a term provenance. It's a proof that whatever document you are looking at is an authentic document. It's hard to explain provenance to you, but it is easier to tell you what it is not. So if you have ever downloaded a software from a website, you go to a website, you click on a button, it downloads a binary for you, maybe an exe, maybe a DMG, maybe a dev file, whatever. And you see just below it, there is a checksum listed there. That checksum denotes that if you have downloaded this software, do a checksum at your end, and if the checksum matches with what we have listed there, then you have a genuine artifact in your hands. Anyone here who is a pen tester or a hacker or an attacker per se, attacker persona, would say, okay, so if I compromise a website and if I change that download link to my source and then I change that checksum there, how would you know? This is where if you have an independent third party who has signed a document and that document is now cryptographically tamper-proof and you host that document even on that same domain, that document gets downloaded, gets verified by the third party, and now you know the checksum value that's inside it is a valid artifact. And that can be used to establish the authenticity of the artifact. That's the whole process could be termed as provenance. Now, like I said, ideally, it should be either the document should be stored at a third party place or you should be able to independently verify it without involving the party that is providing the artifact to you. There should be an independent verification capability. Now, this comes closer towards the end of the talk. So, a lot of things I've talked about. What do you do from here? While you're leaving this room, what are the things you should be looking at? What are the references that you should be going for? So there are some frameworks that I'm going to talk about. There are some tools that I'm going to refer. Again, keeping things in the open source realm, in the public realm, so you don't have to worry about purchasing a license to download a software per se. In terms of frameworks, there are 3 frameworks that you should be looking at. SLSA framework, which is by Google. I'll give a very brief idea about it. Cybersecurity framework version 2, which is right now in draft mode, but that's the version that you should start looking at compared to CSF version 1.1. 1.1 versus 2, there's a drastic difference. Anyone who has ever dealt with the upper management would appreciate that now CSF has a section called govern, which actually talk about how the governance policies should be crafted for having better security in the organization. SSDF is a guideline that is created by NIST. It's not actually a sort of a document which describes the way to do things. Rather, what they've done intelligently is, instead of creating yet another standard that you should follow, they have line items, and for each line item, they refer, hey, you know what, if you're following OWASP SAM, these are the line items in SAM that are corresponding to this point. Or if you're using CSF, these are the line items that correspond to this line item that we are asking you to do. So you don't have to redo everything and say, okay, another framework, another compliance, another checklist that I need to follow. A lot of it would basically become, yeah, I am PCI DSS compliant. I am done with about 20% or rather 30% of this particular framework. So that kind of is a good thing that they have now started doing. So quickly covering these frameworks, SLSA is a framework created by Google and the other parties. Different levels are created to denote the maturity level. Started very ambitiously with version 0.1, where they claimed that, hey, we will have 4 layers. The 4th level would be the highest tier possible. In 4th layer, the organization needs to have reproducible builds. Reproducible builds is a concept where using a known compiler, if you take the source code at your end and I take the source code at my end and run a common script, the output of those two would be bit by bit identical. They started with that as the larger ambition. And then they realized it's not that easy. So version 1.0 that has come out has removed level 4 because it's not something that we want to do right now. It's a future ambition to reach to that point. But it's a good practical framework which has a bunch of different layers to look at the whole chain. So this is how they envision the chain. Very similar to the diagram that I created at the start of the session. Different endpoints or different interaction points that are there between each entity are the points where problems can happen. So what problems can happen? How do you try and mitigate them? SLSA framework tries to answer those questions, primarily focused around producers and the consumers from the 4-party equation that we saw at the start. This is the levels that I was talking about. So level 1 is like, yes, I have documentation. 2, I have built something which can be sort of temper resistant. Second, more better layers are imported. 4th is the level which was supposed to be there, but right now if you go into the documents, level 4 is not there at all. They've said, do 3 levels. By the time organizations reach first 3 levels, we would figure out what to do about level 4. NIST SSDF. So one thing that I hate about NIST, they don't like doing diagrams. So I have to share a wall of text with you. I've tried to reduce it, but these are the 4 top level ingredients that are there in SSDF framework. There is prepare the organization, protect the software, produce well secured software, respond to vulnerability. Anyone who has ever dealt with CSF, they would immediately recognize the kind of flow that is going on, do the identification, then do the protection, then do the detection, and then do the response and then recovery. It's the same flow. So you start by preparing the organization, having people, policy, processes, everything in place, and then you get to writing good quality code, then doing validation around that code, having a process how to handle a security scenario. So let's say a dependency which is like 3 levels down to you has a vulnerability in it. How do you handle it? Do you immediately go like, okay, I need to fix this, so the dependency above it needs to fix it, then the dependency above it needs to fix it? Or do you go and check, okay, yeah, there is a bug. Does it even matters to me? Is it even something that I need to work for? And then decide whether you want to take that decision or not. Now, when it comes to tooling, the top 3 tools that are there. So OSSF scorecard is a very good tool if you are a software developer. And if you're using GitHub or GitLab kind of a CI/CD system in place, you can actually add it as a CI sort of workflow. What it does is, it tries to create a health stat for your particular software. So if you are doing, say, insecure practices in your code, it will try to highlight them. It's not going to find bugs in your code itself. It's going to find bugs in your configurations. So if you have another workflow, it is insecure, it will inform you. If you're using dependencies which are way older, it will inform you. If you do not do a code review, so if there are 5 maintainers of the project and everyone just creates a pull request, merges it manually without having any review, that's a point that it will try to raise, that hey, at least get someone else to review. SigStore is a distribution signing software which relies on cosign, which is the second entity in that list. Cosign is a container signing process. Effectively, they're trying to create provenance. Look at the container, what are the ingredients, what are the checksums, create a report, sign it, seal it, make it available to people. What we are trying to establish is, whatever you were supposed to get is what you got. If that happens, it's all good. The 2 projects that I've mentioned in the bottom are the 2 projects, 2 open source projects that are actually trying to solve this problem in a slightly different tangential manner, but are trying to help the ecosystem. So on one side, we have SafeDep VET, which is a verification tool. It can be integrated into CI/CD pipeline. It could be integrated as a standalone tool that you want to use. What it is trying to do is, it goes through all of your dependencies and tells you what is the current state of your dependency tree and what could be the state, what are the drifts in the system, how many versions you're behind, are there any security bugs, are there any compliance related problems. And the interesting feature in this is, you can create a rule for your organization. So you can have a rule for your organization which says, I don't want any third-party dependency which is a GPL licensed dependency. I don't want any third-party dependency which is hosted on GitHub and does not have any activity for past 6 months. I don't want any dependency which is hosted on GitHub and has less than 100 stars. So these kind of granular capabilities is what you can define as rules, and when it will run, it will show you violation of those rules. Other tools like dependency check also are adding these kind of features. StackLock is one tool that I very recently saw. This is developed by the same people who wrote SigStore. And what they're trying to do with this is going one step ahead. On one side, they're creating a Visual Studio plugin. So as soon as you do that in a Python code, import and type the import module name, it'll give you a squiggly line saying, hey, this may not be the best module that you use. Maybe you want to recheck. But when you click on the link, this is where the good part about StackLock comes into picture. They give you a rating for that module, and then below they list out, hey, instead of using this low-rated module, these are the alternative modules in the same sphere doing similar job but have higher rating available. Obviously, that list is not going to be 100%. That list is never going to match every single scenario possible. But it will give you pointers where to go next. It tries to answer the question, what should I do? Yes, I have a problem. What should I do now? So those are the toolings that you should be looking at. This is a very simple 3 questions that I want all of you to ask any vendor who is selling a SBOM solution to you. What do I do with the SBOM? Ask them, what are the next steps? You have got me the SBOM, what do I do with it? What are the next steps? If their answer is, you don't need to do anything, this is all you needed, you know you need to just find your shoes and run from that place. Second question, if you are saying we will find vulnerabilities in all the dependencies that are listed in SBOM, which is what a large number of vendors would say, ask them, are you just spotting vulnerability based on version number, or are you actually validating that my code has that vulnerability? 99% of the times the answer would be no. It's not an easy problem to solve. Many people have been trying, not 100% success rate, I think not even a 50% success rate at this point on this particular traction. But don't just ask them. Test it also. Have a dependency which is old just for a sample testing purposes. Have a vulnerable dependency in a sample project of yours. Ensure you never use the code path that the vulnerability requires, and then run it against their system. See if they give you that issue back. If they do, that's not a product you want. 3, do you have alternative solutions to the libraries? The Stacklog project that I'm talking about gives you some solutions. It does not have 100% coverage. It does not have all ecosystem coverage. When a proprietary solution company comes to you saying, hey, buy my product, this is the least they can spend their money on. Help me find the alternatives. Where do I go from here knowing that I have a vulnerable software? So this is my request to all of you when you go and talk with your vendors or people who are in charge of buying solutions. Ask them to ask these questions. And that's about it. That's the email address, the website, and the name. So this is where you can contact me, and thanks for being a patient listener. Thank you. And I think I have 5 minutes, so if someone has a question, they can ask. What?
Thoughts on? Hi there, my name's Dave. Have you got any thoughts on COE environments? Things like, I don't know, you've got all these tool chains that say, buy one of my add-ons.
Sorry,
like the modern equivalent of an Excel spreadsheet is a COE small piece of code installed by the user. Have you got any thoughts on these for SBOM?
So let me repeat it. So
the question is, the COE environments, most vendors have them, and their user-installed code base, modern equivalent of an XLS, if you like, piece of code. So the idea is that most vendors have little lumps of code that you can buy, and they go off and do things. In
the larger way, the question is, if there are user-controlled environment where user can install whatever they want to install, and there are pieces that they're installing, what do you do about that, or what can be done about it? So there are 2 parts of it. There's an open source angle around it, and there's a corporate angle around it. The open source angle around it, you can't do much. But if it is a corporate environment, if it's a corporate controlled device, or corporate has some sort of a connection with the device, there are solutions like OS Query that can be installed on the system. It's not going to be a 100% solution, that I can tell you right now. It's not going to find most probably the exact thing that you asked. Excel macro, it's not going to spot that. But it will spot softwares that are being installed on the environment. Most of the time when it comes to macros or programming within the, say, office environment, my suggestion is if you don't need it, don't enable it. try and disable it at the, say, AD level, if possible. But yeah, it's not the practical ground reality that you can have.
Yeah, like a lot of dependency scanners, commercial and open source, list out a lot of dependencies for the project team to address. And the teams, what they say is like, hey, can you give me just the top risk which is applicable to my product or my software? So what are the key parameters for prioritization?
See, there are two parts of it. One, any vulnerability that is discovered, ideally, and this is the big ideal word, ideally, the third party that is providing that library to you should specify of all the bugs that are reported against my code or the downstreams, these are the ones that are applicable to me. Because what you see in the report, most of the bugs would not be in your direct dependencies. The CVEs that you will find will not be in the dependency that you imported. It will be in the dependency that was imported by a dependency of yours or a second or a third level dependency of yours. So someone in the middle would have to identify. One, we can't take that as the ownership per se, but what you can do, and this is where if you have time, money, resources available, and especially if you're a security person in the company, what you should be doing is dig a bit deeper. Don't just look at the CVE, rather try to see what was the function call that is the problem. And is that function actually in use? Make a note of it. It is not in use right now. If 2 months down the line, it becomes something that is in use, you need to spot that and report it. So a tool that helps me, it's semi-commercial, semi-open source, called SemGrep. It allows you to create structures around identifying such patterns. So that can be used totally disjoint, no cloud connection. Have a rule on your system, have the binary in your system, do a check within the system itself. So that can be done, but the initial bit, identifying whether that path has actually happened or not, is the problem that you'll have to solve at your end. You can't just tell the developer, hey, these are 2000 vulnerabilities, fix them all. They will ask for top 10 because their entity or their, mandate is not to fix bugs. Their mandate is features. So you tell them what do you need to be fixed. So code coverage is going to be your first step. Second step would be the CVSS and EPSS scoring. So CVSS scoring tells you what is the general score of the vulnerability. How big of a problem it could be in a generalistic level. EPSS tells you whether the vulnerability is right now being exploited. And there is another scoring called KEV, known exploited vulnerabilities. If the vulnerability is part of KEV index, that needs to be fixed immediately. KEV, that's a list being maintained by governmental agencies around what is actively being exploited. So if they say this is actively exploited, people are actively attacking, so we need to fix it right now.
So won't the tool actually give this?
Some tools claim, some tools do not. It's a bit of a gray area right now.
The reachability and the exploitability are the key factors.
Exactly. And instead of just saying reachability, exploitability, EPSS is the word that you would find everywhere. So EPSS score is what you need to look for.
EPSS?
KEV. Yeah.
That was very useful. Yeah. Thanks.
Thank you.
If there's no question, let's appreciate Anant again. Thank you so much.